In this video, we want to use the sum and difference formulas to find an exact value. And there's sum and difference formulas for sine and cosine, among others. But we're going to focus on these right now. So here's what we have. Have the cosine of the sum of two angles. It breaks down into this expression here. Cosine of a difference of two angles. Here A and B are angles. Breaks down into this. Sine of A plus B. We have this formula. Sine of the difference of the angles A and B breaks down this way. You see there's not much difference between the first two other than the sign, minus plus, and the same thing with the sine of A plus B and A minus B, plus minus there. So when you're working these types of problems, one thing you need to know is your reference triangles. Makes it easier if you know the sine of 60, or the cosine of 60, or sine of 30, cosine of 30, using the 30-60 right triangle. So this again is 90 degrees here. This is 90 degrees here. This angle, of course, is also 45. So from these triangles here, you can find the sine, the cosine, the tangent, cosecant, secant, cotangent of angles like 60, 30, and 45. And then you should know that if you know this, then you can find the exact value of the trig function value of any angle that has a reference angle of 45, 30, and 60. For example, 135. If you want to find the exact value for the sine of 135 or cosine of 135, tangent of 135, well, the reference angle of 135 is 45. So you'd be using this triangle here. And then as far as the sine, whether it's plus or minus, in this case, so that's what I'm talking about, minus or plus, you just have to know where the angle terminates. So 135 has a reference angle of 45 and it terminates in quadrant 2. So if you want the sine in quadrant 2, the sine is positive. Quadrant 3, it's negative. Then you can just use these triangles here. So let's go back to this then. We want the cosine, or sine I should say, of 105. So what we want to do is we want to rewrite this as the sine, either sum or difference, whatever works. So can I find a sum here of two angles, and I want these angles to be either 45, 30, 60, because those I can find exact values for. So you can see here that 105, I can write it as a sum of 60 plus 45. 105 as it is there, can't find an exact value. But if I expand this then, using the formulas we just looked at, the sine of the sum of two angles, A plus B, would be the sine of the first angle, 60 degrees, times the cosine of the second angle, and then it's a plus. If I was dealing with a difference here, then of course this would be a minus here. It's a plus, and then it's the cosine of 60 degrees, and then the sine of this second angle. And then hopefully you've memorized these, or if you haven't memorized them, then you're able to create those reference triangles, the 45, 90 right triangle, or the 60, 30 right triangle. So here, the sine of 60 degrees from those triangles we looked at, or just from memory, just square root of 3 over 2. The cosine of 45 degrees is 1 over the square root of 2, or rationalize it, the square root of 2 over 2, plus the cosine of 60 degrees is 1/2. The sine of 45 degrees, again, just like the cosine, is the square root of 2 over 2. Then we write this as 1 here. So 2 times 2 is 4. Over here, 2 times 2 is 4. So we have the same denominator. So we can put these together. And then radical 3 times radical 2, that's radical 6. And over here, 1 times radical 2 is radical 2. It's asking for exact value. So you leave the answer as. Now, the answer to this one also turns out to be the same thing. Square root of 6 plus the square root of 2 over 4. So we'll just set it up and I'll let you complete this. That's your answer right here. This is what you should get. So what we need to do in these types of problems, using those reference triangles that we went over, you can find exact values for trig function values of 45 degrees, 30 degrees, 60 degrees. So on this one then, I have the cosine of 15 degrees. I want to write this either as a sum or a difference of two angles. That gives me the original. So for the first one, 105, we saw that that was 60 degrees plus 45 degrees. So that worked. So now in this case, you think about it, okay, looks like we have to find a difference here. So we can find a difference here. The difference of two angles, that gives me 15 degrees. And we always want to come up with something like 45, 30, 60. So in this case, you can see it's 45 degrees minus 30 degrees. And then we expanded using the cosine of the difference of the angles A minus B. And if you do that and compute, you should get the same answer. So I'll let you do that, and we'll end the video here. Thanks for watching, and we'll see you next time.